Scatterplot matrix is a useful technique to represent and analyze pairwise correlation between multiple variables in high-dimensional datasets. However, as the number of variables increase, it gets more and more difficult to visualize these details due to the limited screen display, and the visualization become less responsive. To deal with the curse of dimensionality, we propose a new criterion for unsupervised variable selection which computes the dissimilarity of variables via their visual features. The result matrix focuses on the most important features. Common methods for unsupervised feature selection are based on the pairwise correlation of numeric features. The proposed new criterion is based on two ideas. First, the correlation between a pair of variables is measured not directly between the pair, but between the correlations when each variable of the pair is combined with any other variable of the dataset. And second, the scatterplot similarity is based not on one of the standard statistical correlation measures, but on the difference between the 9 scagnostics measures. Using this notion, a similarity score is constructed over each pair of variables in the dataset. Then the leader clustering method is applied to identify groups of similar behaving features. Representative variables from the clusters are selected as the final variable selection. We now demonstrate interactive features of our prototype. After processing and clustering, we bring up a compact and discriminating set of dimensions. The size of each scatterplot in this matrix is decided by its dominating variable or the leader of larger cluster. Details within each cluster can be shown as another submatrix by closing on any diagonal entry of the summary matrix. Details between two clusters can be shown as a rectangle array of scatterplots by closing on an off-diagonal entry of the matrix. We can see that some cluster contains highly correlated variables. But this is not necessarily true for other clusters since our criterion for variable selection is based on scagnostics measures with respect to other variables. As depicted, the 6 variables in this group are not correlated, but they have similar behaving features when combined with a third variable. Instead of showing all pairwise projections in a pop-up window, users can also examine the member scatterplots one by one. Small thumbnails on the top left corner of the window allow users to navigate through different member scatterplots in smooth transitions. Selected variables are displayed in black while others are in green. Green trajectories keep track of how every data point moves between different member scatterplots in this group, which provide a summary of how data values in this cluster extend in both dimensions. The last option allows users to examine the computed visual features of scatterplots when mousing over. The last part of this video shows applications of our unsupervised variable selection on real-world datasets. Our feature selection technique can be seen as guided by the uniqueness of visual patterns the selection provides. It can improve the visual exploration process by selecting those features that give a compact yet diverse set of views. Instead of working with a large number of variables in the input dataset, our method provides a smaller set of representative variables. The compact and discriminating set of dimensions is also useful for an initial exploration and understanding of the high-dimensional data. For large datasets such as the communities and crime, it is not possible to render all data in the original scatter plot. Our approach gives a smaller and richer mix of visual patterns and resulting plots of the summary matrix. More case studies can be found in our paper and project website.